Hey, what's going on, students? Here we go. Let's finish off the 5-1 notes. Rate of change and slope. So there's these other type of problems that might show up and will show up. So I'm going to show you how to tackle these through some examples here. So here we have the corner point 4 and 5, x and 11. What? Here's what's going on. They're giving you the slope, and you got to find the missing x or y value. So in this case, we're missing the x value. So I'm going to rewrite it here really fast. So I don't want to ruin these pretty notes. These notes are for you, not for me. Okay, and the slope is already going to be 3/2. So what is the slope? Remember, the slope is the change in y over the change in x. So the change in y is 3. Well, going from 5 to 11 is plus 6. Okay, going from 4 to x, well, we don't know yet. That's what we're trying to figure out. Oh, here's the clue. So the slope is 3/2. So the rise over the run is 3/2. Well, this one jumps 6. So what's half of 6? Oh, 3. Weird. Okay. So if we reverse that, we'd probably have to jump 4. Okay. How did you do that, Mr. K? Because the slope is 3/2. So if we jump by 6 and we want to keep the slope the same, we'd have to jump by 4. Okay, so this is where the little loop-de-loop method works, where you do change of y as a loop, and then the change of x as a loop, change of y over change of x, and you basically just write it out. So the change in y was 6. We need a change in x of 4 to make a slope of 3/2. So go ahead and finish this thing off. 4 plus 4, x is going to have to equal 8 in this situation. All right, so again, map it out, take time, draw the actual change, and then scale it up or scale it down. This is probably one of the tougher ones because most of the time it's the same numbers. But in this case, we had to scale up our slope to match the jump. Plus 6 and a 3, plus 4 and a 2. Okay, that's the same thing. 6/4, 3/2, that's the same slope. Okay, next one. What happens if you're missing a y value? Well, you attack it from the same method. Here we have that 4 and 5 again. Take my time, rewrite it because I don't want to ruin the notes. Slope's -2. Okay, so change in y. Well, we don't know. We don't know what change in y is, but we do know that the change in x is -2. Okay, so in this case, especially when you have change of y over change of x and the slope simplifies to an actual number, here's what I would do. The change in y over the change in x has to equal -2. That's what slope is. Change in y over the change in x. We already got the change of x. The change of x is -2. Now, what do we need here? What do we need here to get to a -2? Well, what number divided by -2 is going to give us a -2? If you were to guess and check, I'm pretty sure the answer is 4. Okay, 4 divided by a -2 is a -2. Guess what? You could also solve that. Watch this. Times -2 times -2. Oh, look at that. Y equals a +4. Nice. So now we know what the change is. The change is 4. Okay, 5 plus 4, y is going to have to equal a 9. Okay, so don't stop when you actually find the change. Stop when you apply the change. Stop when you apply the change. All right. Now, the ones I don't have here, I don't have one where the first coordinate point is missing. Well, all you would do is if it was vice versa, let's pretend this was 9 and this was y, and then you found out, oh, the change is +4 going this way, you would just reverse it. Oh, 9 minus 4 would be 5. Okay, so if you have to go backwards, then you literally just go backwards mathematically. Okay, so that's the type of problems that you are going to see where they give you the slope and you're missing an x or a y, and you've got to find the change in y or the change of x and then apply it. Okay, see you in class.